Hello everyone, good morning. Hope everyone is doing great. Let's wait for a couple of minutes for others to join and we will start at 11:03. Okay, so welcome all, welcome to Power BI series, and this is the first part of the series where we are going to discuss about the basic concepts. Uh, So, if you don't know Power BI, and I would be very honest, you are already late. There are lots of developers available in market, but only 5% of them are able to build the robust solutions. So there are lots of people, but there are only 5% of people, almost 5%, at least 5% of people only can build the robust solutions or scalable solutions. That's why we wanna, and to build the robust solutions, you must need to be aware of all the basic concepts. You should understand the tool. So most people learn the concepts, but they don't understand the tool, right? So the architecture of the tool, how tool works, how tool takes the data in, right? So they don't understand the tool. But in this series, we are going to cover in and out of Power BI. So we will cover what happens behind the scenes of Power BI, and we cover all the basic concepts that takes you to the top 5% of the developers available in market. Though it's late, but if you follow this series and if you practice regularly and if you understand the concepts well and right, then you can go to the top 5% of the people. So being that said, let's start with the agenda of today's session. One first thing, as I said in agenda, so we are going to discuss about the computer. So what is a computer in your opinion, and what is the language of computer? Does computer understand the regular English, or how does the computer understand, right? It understands the binary language. And we also discuss the hardware components of a computer or a machine, right? And second one, we're going to talk about strings versus numbers. And third thing, the very important thing is, what is data? I mean, what is data in your perspective, and why do we need to collect the data, and how to store the data, right? So we need to know, we will talk about all those things. And we also talk about the structured versus unstructured data, right? So what is data, why, and how the data is stored. Structured versus unstructured data. And then we will talk about few data warehouse concepts. I'll not go in detail, but I'll talk about the very basic concepts, like what is the dimensions versus facts, and then star schema versus snowflake schema, and then OLTP versus OLAP, and fifth one I'll talk about on-prem versus cloud. On-premise versus cloud sources. And then we will end up introducing BI and Power BI. So you may be wondering why we are discussing all these concepts, but these are very, very essential if you want to build a scalable solution, right? So whatever the solution that you are going to develop or deploy, it's going to be on some or the other machine, right? It could be a local computer, it could be some cloud service, right? So to build a scalable solution, you must know the hardware components, and you must know all the data ware. You don't need to know all the data warehouse concepts, at least basic ones, the ones I show here, right? And these are like the few dots. These are like some random dots. Down the line, once we move forward in the upcoming classes, we can connect dots, and you will understand the importance of it. So being that said, let's move to our first concept. Okay, so computer, what do you mean by computer? You might have heard lots of definitions for computer, so I'm going to define one today. In my opinion, computer is a dumb machine. It just knows ones and zeros. It doesn't know more than beyond that, right? You might have heard computer takes only 0 and 1 encoding, correct? And it understands only binary language. What does binary means? Binary means 1 and 0, right? So two things. By 2, it understands only 1 and 0. But have you ever wondered, if computer understands binary language, do you know how does it takes the numbers as input? How does it shows us images, right? How does it shows the text, right? If you enter Bharat, it shows you Bharat. It doesn't show you zeros or ones. How come it shows that, right? And you hear music in computer. If computer understands ones and zero, how come you are able to listen to music, right? Or movies, you watch movies, right? So to learn that, I'm not going to cover entire thing, but I'm going to talk about the glimpse of it. Like I will show you how does computer converts the regular input to a binary, right? So let's take 29. So let's take 29 as your input. If you want to convert 29 as input, so you can do like this. 7 reminder this is the reminder when you do with a 0, and 2 3 is a 6, and 1 is the reminder. 2 1 is 1, 2 0 is 0, and 1 is reminder. So you need to do until you get 0. Now if you write it in 1 1 1 0 1, this is how computer reads 29. Okay, so if you want to cross check, you can take it like a 2 power 0, 2 power 1, 2 power 2, 2 power 3, 2 power 4. 2 power 4 is 16 plus this is 2 power 3 is 8 plus 4 plus 2 power this is 0, so it comes 0. 2 power 0 is 1. It rounds to 29, right? This is how it converts. This is how a computer converts into binary form. And if you give the text, right, you may wonder how come it converts the text, right? Let's take Bharat, right? Even its numbers, it divides by 0. That is perfectly fine. It converts into binary form. Very perfect. How come it converts the text, right? And to know that, you might have heard ASCII, Unicode, right? There are different encodings available. So ASCII, if you look at this table, this is the ASCII convention. So you see, right, these are for every character. There is null. If you see, there is null. There is 1, 2, 3, 4, 5, 6, right? For all the digits, there is an encoding. This one is the encoding reference for a computer. So if I wanna give B stands for 66, and I have given small h, right? Small h stands for 104. That's the reference, and small a reference is 97. So if you look at this encoding, so computer converts this B as 66 and 104 as H, A as 97 from the reference of above table, and it converts each digit into a binary form. And for you, it's a Bharat, right? You look at this text as a Bharat. For computer, this is how it reads Bharat, right? This is how you read. This is how computer reads Bharat, right? And yeah, and similarly, even if you take a pictures, right? So pictures, you might have heard about pixels. So all the pictures will be split into this grid form, and each grid will be given a different number, and based on that it will read the pictures as well, right? More pixels, if you have more resolution, right, you get more clarity. That's the reason. So if you have more resolution in your when you take pictures, it will be more clarity. That picture will have more clarity, right? Because it takes more number of grids, right? So it can capture that much details. So that's very high level, like how computer reads numbers or text. Why I'm saying is, any data that you try to interpret, right, it could be either form of a numbers, it could be a form of a text, right, it could be form of images, it could be majorly these things, right? Most likely you will be evaluating these things 95% of the times. So it's very important to know how this data is consumed by the computer. And so hardware, if you want to talk about hardware components, so there are three hardware components, I would say, as a measure ones, like a RAM and storage, or hard disk, you would call hard disk, and then CPU, right? Whenever we try to buy a laptop, people always say 16 GB RAM and take 512 SSD and take 8 core i7 processor, right? So they talk about they mostly talk about the hardware components, because your laptop, your machine performance is directly related to the hardware components that you are going to choose. Let's take one example. Let's say you take a 8 core mission, 8 V core mission versus a 4 V core. So assume each V core like a one traffic line. Okay, assume like a highway. If there are 10 cars here, if these 10 cars have to reach the destination from one lane, it may take X amount of time, right? Let's assume 10 seconds if one car takes 1 second to pass from this tunnel. On the other hand, if you have two lines, how much it takes for 10 cars? It takes only 5 seconds, because at a time this highway can take past two cars, right? It takes only 5 seconds. So if you have more CPU capacity, if you have more codes, it will process multiple requests in parallel, right? It quickly executes all your requests. On the other hand, RAM stores the temporary. It's a temporary storage. If you have something in RAM, if you shut down your laptop, you can't revive it. You can't get it back. That's a temporary memory. And storage is a permanent memory. If you store something in your hard disk or in your storage, if you close your system, if you close your laptop, if you reopen it, you still have it because it's a permanent memory. And RAM is also very crucial for CPU. Whenever your CPU have to process, it takes the RAM's memory. It keeps that chunk of application or that chunk of data in RAM and analyzes it. So RAM is also an important component. So more RAM means it can have more data in cache and it can process more, right? Storage is directly functionality. So if you have more storage, you can dump more data, more and more information in it, right? Okay, so and let's move to the second one, strings versus numbers. In most of the data, we look at the strings, right? We look at the strings and numbers. I was showing you how we can encode Bharat and how we can encode a number, right? If you take Bharat, if you take a number like Bharat is a 7-digit character, and let's take some random number like 2000 or 456, right? Let's take these two numbers. Okay, these, out of them, this will take the more length, this will have the more length, and this will have the less length because it's a number. It will it will be converted into binary in this way, right? The length will be relatively less if you compare to a string, right? So if you have a more length, computer takes more time to compare, more time to process, right? So that's why strings take more memory to store the data, and it takes more time to process the data. I should have an example, I don't find it, but yeah, I will try to present the example at the end. And yeah, moving to the data. So what do you mean by data? Like I'm sorry, give me a minute. Yeah. Okay, so what do you mean by data? And why do people collect data, right? So data refers to raw facts, figures, and symbols that represent an information. And this could be a number, it could be a text, it could be an image, or it could be any form of the input, right? So if you talk about data itself has no meaning until you process it or until you interpret it, right? So that's data in my opinion. So, and why do you need to collect the data, right? So you must have if we need to take one example, I would say recent elections. Lots of people gave surveys, right? So lots of people gave predictions. Out of them, few succeed, few fail. How were they able to give the predictions? Because they collected the data. They did surveys and they did collected the data from people, and they interpreted the data. They used some techniques and made a conclusion that this party is gonna win, that party is gonna win, right? So data is that department. So you can make predictions with data. You can take the analysis, you can do the analysis, and you can understand what is the trend, right? And if you want to take one more example, we can take supermarket example. Let's say you have a supermarket, right? And you need to open a new branch, right? Where do you open it? So based on the data, if you have the data, if you have all your customers information, their address and all, it will be very easy to take decision, right? You can open a new branch very near to your customer base, right? Wherever you have most concentrated customers, you can open there, right? So it will be easy. It gets success if you open in that place, right? So you can take informed decisions with the help of data, right? And you can predict if you can predict sometimes, right? You can use machine learning algorithms and all, and you can predict uh, the future trends. So that's the importance of data. And how data will be stored, right? You collect the data, that's fine. Where do you store the data? You should save it in some or the other way, right? So most of you might know Excel is very easy. You can save the data in Excel, correct? So and Excel is limited to 1 million rows. If it crosses more than 1 million, it can't save. How do you save if there is a massive volumes of data, right? For that, there are other options like a relational database management systems. You might have heard of SQL Server, right? So it is one of the database where you can save, where you can share host unlimited data, right? So there are various sources like Excel, there are CSVs, there are lots of cloud sources if you talk Snowflake, and there are traditional SQL servers, and various, there are other many, right? So there are various sources available. And if you talk about Power BI Connect, you can get data from majority of the sources. There are direct connectors available within. There are pre-built connectors available, right? And structured versus unstructured data, right? So that's something we have to cover. So structured data, the name itself, the word itself has the meaning, right? Structure. It's predefined. It's a fixed data, right? It's a predefined data. And unstructured, it has no structures. If you take images, right, random images, it'll have no structure, right? You can just store it in a data lake or wherever. Let's take audio, let's take video, right? They all are the unstructured data. If you take some data in Excel, in a SQL, they are all structured data, right? So you save them in rows and columns. They are very structured. So here are some storage options for structured and non-structured data. And to process the data, right, to get the data from SQL Server, you must know the SQL language, right? And yeah, these are the few examples. I'll share this file with you. You can go through all the comparison. Okay, so moving further to the data warehouse concepts. Before that, let me share you something. Okay, so let's say you are running a supermarket, right? You will take the data for analysis. Let's say this is the data that you are taking up. So you are taking member ID, you are taking mobile number, you are capturing the name, a product, a quantity, so let's say if you are running a discount or offers, right, whether that people is availed any offer, like the address of your customer. If they have the membership ID, right, they would have filled all the forms. So you'll have address 1, address 2, city, blah blah, right? This information. Let's say 1002 is a member and his mobile number is this, and let's say the customer name is Bharat and he purchased product A of quantity 2. He didn't avail the offer, and this could be his address. Okay, and if I purchase another product, it will save like the same Bharat product B. Let's say on product B there is a 2 plus 1 offer or 3 plus 1 offer. I would purchase, I would take this offer, right? So I took 4 quantity, 3 plus 1, right? So you save in this way. This is one example, right? If you see, there's a duplicacy in data. I have different products. We captured it in different lines, but my address is same. My member ID is same, right? My member ID is same. My mobile number is same. My name is same, right? My address is same. So you are duplicating all this information, right? So instead, if we save data in a way that if we divide it in two things, dimensions and facts. Let's say dimension table has the same thing. Okay, maybe let's say this is a dimension table where you will let's say this is a customer dimension table, right? You are storing all the customer related details. Let's say there is a one more table that is a fact table. And let's say this is a member ID. This is a 1002, 1002, right? This is the fact table. Let's say sales fact table. Okay. If you save the data in this way, you no need to create all the additional columns, right? You no need to save all these additional information that you saved here, all the ones in red mark. You can save it as a one, right? And you can create a relationship between this versus this. So whenever if you want to know who is this 1002, you will refer this table and you get all the information from here. In this way, as I said, right, so strings will take more space, right? If you here you are repeating the strings, address is a string, city is a string, member name is a string, you are repeating the string multiple times, so it will take more space. And even if you want to run query, this will run fast compared to that, right? So dimensions, basically I'll compare in the next slide. So if you see the dimensions provide the context and descriptive information of an attribute. If you look at this table, this is a customer dimension table. It talks about the customer attribute. It gives you all the details of that customer. It could be member ID, it could be number, it could be name, address, right? All the other details regarding this attribute. This attribute is a customer, right? So dimensions will provide you the context and descriptive information of any attribute. Facts contains the quantitative data. If you look at here, this member ID purchased what? A product A. How many? 2, right? It could have price. It is giving the actual factual information which you need to run the analysis, right? So fact table will talk about all the quantitative measures, all the quantitative data, right? So fact talks about all the quantitative data, and it's mostly textual or categorical, like how in previous example we saw, right? It was talking about customers, and it talks about all the numerical data, how many products, what was the price, and how and the other whatever the other factual information. If there is a discount at the time of his purchase, it would give information about that, right? It gives you the all the factual information. And examples, I was referring the customer table, and you can similarly create a different table for product 2 and reference and replace this with product. Let's say you can create a product category, product ID, product ID is 1, 2 is B. You can replace this 1 and 2, right? So you can have such different dimensions like a product dimensions, customer dimensions, and date dimension, which are important, right? When he purchased it, right? And the facts contains the sales amount, how much quantity he purchased, what is the revenue based on his purchase, right? So these kind of information you will store in a facts table. Okay, and usage, right? So when do you use this? If you want to filter the data, right? If you want to filter the data, you mostly refer it from a dimension table, because it's going to be a very short table, right? Because it won't duplicate the data. Let's take, if you want to use a filter, if you get the data from, if you want to use a member customer names, right? It will give you the duplicacy, right? It will give you two numbers. If you take it from a dimension table, it will give you a one number, one ID, right? So it will avoid duplicates and it will take less time to process it, right? When you filter to data, we will talk more about in detailed classes. Okay, and fact table is used to perform the calculations, right? So if you want to know how much quantity you have sold, where do you get that information? In fact table, right? You do all the aggregations on fact table. That's a quick thing on dimensions versus fact. I think you got at least some idea what is a dimension table, what is a fact table. Now let's move to a modeling thing. So what is a star schema? What is a snowflake schema, right? If you think this is a fact table and all these are a dimension table, in a model, all the dimensions, if all the dimensions are directly connected to the fact, that is known as star schema. That is called star schema, right? And if your model has a fact table, there are dimension tables directly connected to it, and there are few dimension tables. If you see this dimension table, it's not directly connected to the fact table, it is indirectly connected. If you want to know the one example, let's say if you have a sales fact that we were talking about in previous example, let's say you have a product table, right? And there could be one other table called product category. Your product category information may not be available in sales, but that will be available in products, right? So your product category doesn't have a, but it is indirectly connected to your fact table. So if you have a dimensions that are indirectly connected to your fact table, that is called a snowflake schema. So you can see one example here. So there is a sales fact table, and you can see time dimension. This is a, let's say, brand dimension. This is a branch one. This is location. All of them are directly connected, right? This time is directly connected with time key, right? Branch connected with the branch key. If you see this kind of model, that is called as a star schema. And snowflake schema, if you see here, I was referring indirectly connection, right? So if you see, there is a city key directly available, right? Location key, I think, yeah, location key is available between these. And if you want to know the more information about that location, right, if you want to know the city, know the state, so you need to use this connection, city versus city. You can get that information from here, right? You don't have that information here, neither here. If you want that, you can get it from here, right? So this fact table and this dimension table are indirectly connected, they're not directly connected, right? This kind of modeling is called a snowflake modeling. Okay, so let's move to the other important concepts in warehousing, which is OLTP versus OLAP, right? So basically, any business, right? So if you want any business to get success, you must follow and you must run it in a good way, right? I'm not getting the right word, but you should know your business first, right? You should know your business, and if you have to analyze your business constantly, let's say you have a 4 supermarkets, you have to constantly monitor them. You have to see what is the sales there, what is the profit in each store. If one store is giving you losses, right, you have to either shut down or you have to think of a new way. You may need to announce a discount, right? To make those kind of decisions, you should constantly analyze your business, right? And on the other hand, you should have the data. First, if you want to analyze, right, you should have the data. If you go to more, if you go to any Reliance market, right, they take all your information. They'll take your information and save it in a way, right? Let's take this example. Okay, let's take this example. So if you go to a supermarket, they will ask you, okay, what's your mobile number and what's your name, what is your product, blah 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 blah, right? They save all this information. First, they save it for business purpose, right? They save in this way, which is for a transactional thing. Whenever you do a transaction, they will save the data in this way, right? And whenever they have to analyze, they will, once they save the data, right, they will modify the data in this way. They will change the data, they will process the data. You might have heard about the ETL process, right? They use some ETL or ELT processes. They will extract this data, they will transform this data into these tables like dimensions and facts, right? So let's say when you are doing a business, right, whenever you are doing a transaction, what happens if you save data in this way, right? This way, if customer comes, you have to first check whether that customer is part of this table or not, right? And you have to check in the quantities and everything here, right? You have to insert in 2 tables, and those are 2 different tables, right? It will take more time. It may break your process, it may slow down your systems, right? That's why you enter the data in this way, in a straight line, in a one single row, and then you will process into this second one. If you take this as 1, if you take this as 2, so this one is called a OLTP, this one is called a OLAP. So on a transactional purposes, whatever the data that you save or collect for transactional process, that is called OLTP. Whatever the data that you collect for analysis purpose, whatever the data that you store for analysis purpose, right, that is OLAP. T stands for transactional processing, A stands for analytical process, right? So that is OLTP and OLAP at very very high level. Okay, now let's move to the on-prem versus cloud, right? So you may have heard like on-prem and cloud. What do you mean by that? Let's say if you go to any bank, right, or any or if you take a bank, or if you notice, they would be maintaining a server room, right? So they will host all the servers, right? If you host your servers, right, let's say if you store some data in your Excel, where do you store it? You store it in your local laptop, right? You are hosting the data, right? Let's take a simple example, mobile phone. So if you save all your pictures in gallery, it is like on-premise. You are saving the data with you, right, in your mobile, in your local storage. Let's say you are, so since if you have that 2 GB memory, if it is full, right, you have the option to store in a cloud like a Google Drive, right? Google Drive, you don't manage it. You either pay for it, you pay for the storage, and you put your data there, right, in Google Drive, right, in one drive. or in Apple Cloud. You put data there, but you don't manage it. You just have internet connection. You connect to that drive, or that Apple Cloud or Google Drive or OneDrive, and you fetch the data, right? And you pay for them because they are maintaining your data and you pay for them, right? So this simple example illustrates you the difference between on-premise versus cloud. If you host your servers, if you host your data, right, with you, within your premises, right, that is on-premise. You are maintaining it. You are responsible for it, and no one can't. You will have the utmost security, right? So because you are not you are not allowing others. On the other hand, if someone else maintains on behalf of you, in Google Drive it could be Google, in Apple Cloud it could be Apple, right? If someone, the third party people, manage data on behalf of you, that is a cloud, right? In cloud, people, someone else maintain the data for you. You no need to worry about the storage if you host your images on Apple Cloud, because you can pay for them, you can increase it. On the other hand, if you want to increase the memory for your mobile, right, how can you do that? You need to go and buy a cheap external memory card or something, and you need to insert into your mobile or computer, right? In computer it is a hard disk, if it mobile it's a memory card. That's a simple illustration to give a difference between on-premise and cloud. Let me compare. Let me give an elaborate comparison, right? So it is on-prem, it is cloud. So if you host your data on premise, right, you will have full control of it. The hardware, softwares, everything, you maintain it. So you have the control of it. If you host it on cloud, you will have less control, right? Because they manage it. You never know what kind of security system they have, how they are controlling it, right? They may share with someone else too. You never know, right? So these are managed by third parties providers, so you will have less control on your data. And customization, high level of customization, right? Let's say you want to import a library, right? You can easily do it because it has in your control. But here it may not be possible, right? It may not be possible because that provider should have those resources that you want to inbuild, right? That you want to patch. And security, potentially higher security, because you are going to manage it. You will not allow anyone, right, without your permission. This will also have more security, but it depends on the provider, right? So if it is a reputed provider, they will have super strong, robust security, right? And latency will be low. Latency is something when you try to access, there may be a delay, right, in accessing things. That is a latency. So you will be here and your data will be stored in some data center, right? If you want to access the data, it has to come from there, right? It has to come from there, and then only you should be able to access. So there will be more time to process, right? The data takes time to come. I mean, it will be very less though. So that's the latency. The latency is less in on-premise because you might be working very close to your data, right? You might be sitting in your office and your server will be in your office, right? So there will be less latency. And compared to on-prem, there could be high latency, right? Based on the internet, because whatever you do, you're gonna do with the internet, right? You're gonna fetch the data from a data center, right? And cost, it is very high upfront cost, right? So when you wanna buy, you have to pay for it. You have to own all the resources, and you have to maintain it, right? If you have a server room, you should provide AC, and you should have a dedicated human resources to manage it, right? It's not only things that you're gonna purchase, but you have to bear the maintenance cost as well. And if you compare with the cloud, it is a low upfront cost and pay as you go. In this case, let's take this case, you brought 32 GB. If you need more, you have to go and purchase and you have to install yourself, right? On the other hand, in cloud, if you have 32 GB, if you want additional 32, you'll just with a click You will pave them and immediately it will be added, right? You can avail this space, right? So it will be easy, and it is easy to scalable as well, right? So here it's very easily scalable. In this case, you have to go purchase, install, patch. It takes time to scale it. And maintenance, as I said. So if you are or your organization is owning an on-premise network, you have to bear. You are the responsible person who is gonna maintain it. If you do with the third-party providers, they are the responsible persons. You are just gonna pay them, and they should take care of everything, right? And same goes with the accessibility. So you will have on-site accessibility. Either you will connect with VPN or something, right? You can connect wherever you have internet. You can sit in your home and connect to this. You can be in vacation and still connect to this, right? So, and compliance. So here it is. You can put more restrictions here, and it is very easy because it is in your control. You can frame a rule easily, right? This is a bit quite challenging. You still have most of the compliance things in your control, since it's maintaining by third party. We never know, right? So it'll be bit challenging compared to on-premise. And innovation, it is hard because you may have brought one server, there may be new updates, and your server may not be compatible with the new updates, right? New technologies or new updates that's gonna come. In cloud, it is very easy, right? They take care of it. They will do the patches, right? They access to the latest technologies and innovations, and they'll always be aligned with that, right? So it'll be easy for them. Yeah. And use cases, if you have very very sensitive data, right? The banking clients, right, they don't prefer data to put in cloud sources, right? If you have a more robust compliance policies, right, if you have more regulatories, then go with on-prem. If you are a startup, if you have the advantage, I mean, if you want to leverage the remote working capabilities or big data analytics, right, so it's you can go with the cloud. And to be very honest, every market, every top vendor, right, let's take Amazon, Google, or Microsoft, everyone is providing cloud, right, cloud services, and they are most reliable now, and they are easy, pretty much easy to acquire and implement and maintain, right? So most of the organizations are taking cloud, switching to cloud, right? Yeah. And and so let's come to the final one, a BA. What do you mean by BA? So far we have spoke about all the concepts, right, individually. We will definitely connect them. We will connect all these dots in the concepts when we teach Power BI. But before that, you collect the data. Okay, what do you do with the data? Let's say if you are a owner, right, I'll collect the data and I'll present you in this way, right? I'll present you all the Excel information I saved. It could be a database, it could be anything. What do you understand by this? Will you be able to take any decisions with this? No, right? You can't take any decisions with this. So if you have to take decisions with this, it should be you should be able to understand this data easily. You can't go and read every line, right? You can't go and filter. If you want to know the mail, right, mail quantity, let's say, you have to filter here mail, and you should know the quantity, right? It's difficult. So you can still unpivot the data in Excel too, but it has its own limitations. Instead, if I show your data in this way, right, it's amazing, right? You can easily know what is your sales information, how many quantity you sold, right? What is your profit, how many unsold items you have, right? So you can release offers on this, you can give discounts on this item to sell them, right, to sell them. So you have all the list of items, you know the top contributor of your sales, right? You know which, if you see, this is one of the interesting items. So you are selling the clothes majorly, so you will know what is the top product, right? So within clothing, what is the most sales by product subgroup. Within clothes, men clothing is has the major portion of business, right? And women's clothing is comparatively less, right? And children's cloth is equally competitive with the women's clothes, right? So you can take decisions. You understand your data very easily, right? And if you see here sales by division, and you get to know the all unsold items, right? So you get to see unsold items. You versus this data versus this, which one you understand easily, which one a business user understands easily, right? Definitely this one, the dashboard one leads, right? So transforming your raw data like this into a much easily understandable dashboards is a BA, is a business intelligence, right? So you are giving insights of your data, you are giving insights, right? So with these dashboards, people can easily take decisions. Let's say if you are in a civil engineering field, right? Your company may be managing 10 projects or 20s of projects, right? How do you how do your owner monitor all the projects? He has to go visit and monitor it, right? It takes time. If you are capturing the data in some or the other way, it is easy. He can sit at his home, he can see the progress of each project versus target, and he can talk to the concerned person, right? He can take actions. And if you are on a visit site, he can go to the site which is performing very low, right? If someone has this dashboard, they can sit home and take decisions. They can execute with their team, right? It is that simple to take a decisions with a dashboard. And for whomever, right, whomever are going to use these dashboards, all the BI people will transform this raw data into a useful insights. Thus BI. To explain one line, converting raw data into a meaningful insights. That is BI, right? I think everyone got what is BI. Now, what is Power BI? To do this, right, to convert this data to this one, from raw data to dashboards, there are lots of tools available in market. There are so many vendors who provide different tools. Microsoft provide Power BI, Salesforce offers a Tableau, and there are these two are very popular ones. And there are other tools such as there's a SAP BI, there's a Sisense, and there is a ClickSense, ClickView, right? And Amazon provides InfoSights, I think. QuickSights, yeah. Amazon provides QuickSights. Google provides Looker. There are various tools available in market to do this job, right? And out of them, the current leader from the past 3 to 4 years is a Power BI. Power BI is like a very affordable solution. It comes at a cheap price, and it takes it pulls off medium to it pulls off low to medium sized solutions very easily at very less cost. And Power BI can be leveraged by a supermarket owner to a multi-billionaire company, right? So anyone can own that. There are different packages, there are different cost levels available based on the requirements. So yeah, that is a Power BI intro for you. And that's it for this session. I know it became clumsy in between, so yeah. And in next session we will start about the true Power BI. We will confine more to Power BI things, and we will connect all these dots, right? So if you take a OLTP versus OLTP, we will connect that. We will talk more about that. If you take a star schema versus snowflake schema, star schema is very highly optimized for Power BI. Why is that, and how to build your model in a star schema way, right? So those things we will talk in future, and I mean in upcoming classes, and we can go in detail about all these topics. I hope it is helpful in some or the other way. I hope you understand it to an extent. Thank you everyone.